of city assets, such as snowplows, which utilizes Google's purpose-built asset tracking platform, Tracks API, allowing city managers to better manage, track, and prioritize moving assets real-time in the field and optimize these assets over time. Upon loading the application, a city manager is presented with a custom-styled map view of Manhattan in New York City. On the left-hand side, the manager is provided with a set of layers which can be turned on and off depending on what they wish to view, along with the ability to retrieve historical information about snowplow tracks and positions over time. Understanding where your assets are at any given time and what they are doing provides key insight into day-to-day operations. To view a live position of snowplows on the map, a city manager simply clicks the Plow Prompts checkbox. This action immediately retrieves a current position or crumb of 3 snowplows in Manhattan from the Google Tracks platform, along with an indication of where they are and where they've been today. Ensuring that the snowplows are deployed in a manner that alleviates the majority of congestion caused by buildup of snow is also key to efficiently managing snowplow deployment and operation. By utilizing Google's traffic layer, a city manager can immediately see traffic congestion on a map in relation to the live position of snowplows. Dark red-black segments indicate heavy traffic and could be an indication of significant snow buildup that is wreaking havoc on commuters. Dispatching snowplows to these areas may be a more optimal use of their time. Understanding where the most amount of snow has fallen in a city is also key to better delegation of snowplows to heavy snow regions. The Google Maps API allows users to visualize heat maps from point information, for example, snow measurement sensors in a city to better understand where snowfall is heaviest and to better delegate assets to these particular regions. In some instances, a city manager may want to contact a plow driver or ascertain information about the last recorded address they were at. By clicking on the plow, a call can be made to the Tracks API to retrieve the last recorded address of the plow. The Tracks API also provides the latitude and longitude of the last recorded position as well, which can be used to retrieve or provide a static map view of the last recorded position and street view image of this position, giving the city manager complete insight into where the plow just was, what's in that area, and what that area looks like. In some cases, citizens may report that their street has not been plowed. For example, let's assume that a user reported that their street had not been plowed on February 14, 2012. In order to verify this, city managers need to review plow route assignments and dates and times of when those routes were plowed. Oftentimes, this can come from a variety of disparate sources and may not be accurate. Using the Google Tracks API, historical positions and routes of an asset, in this case a snowplow, can be retrieved between various epochs of time. To validate the address of the complaint, Google's geocoding capabilities can be used to instantly plot the position of the complaint on a Google map, in conjunction with the historical track. Entering in the address, the map zooms directly to this address, and a manager can immediately verify that, indeed, this street has been plowed on February 14, 2012. Finally, a city manager may want to review the total costs incurred for a particular plowing activity. The Tracks API, in conjunction with the Google Maps API, can be used to ascertain information such as total distance traveled for each plow, and average speed, which can then be used together with fuel costs to estimate the total cost of a particular trip or route. This information can then be used to help understand where costs are originating and to better optimize routing and assets so as to reduce costs going forward.